Right, so again, here in section 2.3, we're just working with more transformations. These are mostly stretches, shrinks, and flips. So you've already done some where I give you the function and ask you to describe the transformation that's occurred. This is our second kind of question, which is if I'm describing the transformation, then you need to write the equation for the desired transformation. Okay, again, in this case, we're all starting with one of our 9 famous functions, square root, squaring function, and so on. And then we just have to change it a little bit. Remember, in this section, when we deal with stretches and shrinks and flips, it's usually changing through multiplication. When you change through addition, subtraction, that's a translation or a shift. Stretches, shrinks, and vertical flips or reflections are all multiplications. Okay. So in the first one, again, we start with the square root function. So I'm just going to write that down. That's one of the 9 famous function we're starting with. And we want to reflect across the x-axis, which remember is a vertical flip. So here's our x-axis. When I talk about across the x-axis, right, you're going to flip top to bottom. So again, I would think of that as a vertical flip. It changes the y's. It makes positive y's down to negative and negative y's up to positive. So you have to be changing the y's, not the x's. So nothing happens to the x. After you do the square root, then you're going to change the sign, which means you just need to put that negative out there. And the second one, we have the squaring function. So again, we start with y equal to x squared. It's going to be horizontally shrunk by a factor of 3. So remember, horizontally means something has to happen to the x before it gets squared. Okay? So the question is, it's not addition or subtraction because it's a shrink. Now again, remember, shrink, we want to think of it that it's going 3 times faster. So again, don't think of when it's shrunk, people tend to think, okay, I want 1/3, but that would make it go slower and drag it out. If you do a horizontal shrink, everything goes 3 times as fast. So you just put the 3 right there. Okay. Now, sometimes you'll hear it said it's horizontally shrunk by a factor of 1/3. It's getting smaller. It's getting squeezed in horizontally. Okay. That happens when you multiply by a number bigger than 3 because it makes it go faster. Okay. Next one is the cubing function. So again, we're starting with this. Again, it's horizontal. So we already know that something has to happen before I cube it. It's stretched by a factor of 4. So what should I do to the x to stretch it by a factor of 4? It means we have to slow it down. It has to go 1/4 the speed. And again, you have to be real careful about these two. Multiplying by a number bigger than 1 horizontally makes it go faster. So it shrinks it in. When you want to stretch it out, that means you're slowing it down. Okay. And then finally, the absolute value function. Okay, we have a couple things here. We have a vertical shrink by a factor of 1/3 and a reflection across the y-axis. But again, so again, if we're going to reflect across the y-axis, that's this way. So that would be a horizontal one. So when you reflect across y, all these negative x points become positive and vice versa. So that has to happen to x. So the vertical part will happen outside, but something still has to happen inside because of this. Again, reflection means you're just going to change it. You're going to change all the positive x's, negative x to positive. And then the vertical shrink part, okay, vertical means it happens after you absolute value, so it has to be something out here. And again, vertical shrink means everything gets multiplied by 1/3, so we don't have to worry about that. Okay, keep in mind in this case, because of absolute value, this would be the same. It should seem reasonable that when you reflect that V shape across the y-axis, it actually doesn't change the shape at all. Okay, and then the last part is when I ask you to regraph. Now notice what I don't have here are any problems where I give you a graph of one of the 9 famous functions. It's sometimes a little bit difficult to see, especially the stretches and shrinks on the 9 famous functions. But if I give you a graph that looks like this, it's a little bit easier to see if it gets stretched horizontally, or if it gets flipped, if this gets stretched higher or lower. Okay, so with a graph like this, it's a little bit easier to see where the peaks and valleys are going. Okay, so again, we have to compare these two graphs. Okay, so you're looking at this original, and we'll take this first one. Well, clearly what was going up to a height of 3 is now only going up to a height of 1.5. Okay, the left edge is -4, the right edge is 5, so nothing happened horizontally. It's just that it's not going as high, so it's a vertical shrink. So whatever the function was, f of x. Nothing happened to x. Horizontally, it looks the same. Vertically, what was going up to 3 is now only going up half its height. So it would just be 1/2 of f of x. Okay. Again, comparing the original to this one, well, clearly a couple things happened. This flipped, right? So this flat part is now, instead of going to the right, going to the left. So it got flipped across the y-axis. That's, remember, horizontal. Positive axis becoming negative, negative becoming positive. So again, in this one thing that has to happen is you have to have that horizontal flip. Okay. Now I would just make sure that it went as high. So this was up to 3. It's still up to 3. So nothing happened vertically. This flat part's was at a height of 1, is still at a height of 1. So nothing happened vertically. This is just a horizontal flip. Okay. And then the last one, and again, just make sure you're comparing to the original. Okay. So I'm going to have to kind of move up and down here. So notice this went from -4 to 5 horizontally. And when you look at part C here, clearly it's not going so far. It's only going from -2 to 2.5. So it got shrunk in. Okay. The top value here, the height, still reaches up to 3. Down here it reaches up to 3. So it doesn't look like much is happening vertically. It's just that those ends, right, that we're going from -4 to 5 get squeezed in to -2 to 2.5. So this is a horizontal. So something happens to the x before we do the function. Remember, shrink, it's going twice as fast. So when it gets sort of shrunk by a half, really, it's making it go twice as fast. So it would be y equal to f of 2x.